This is stochastic process, module 5, continuous time Markov chain. Lecture 6, queuing networks. In the last 5 lectures, we started with the definition of continuous time Markov chain, then Kolmogorov differential equation, Chapman-Kolmogorov equation, infinitesimal generator matrix in the lecture 1. Lecture 2, we discussed the birth-death process. Lecture 3, we have discussed the special case of birth-death process, Poisson process. Then the fourth lecture, we have discussed the application of a continuous time Markov chain in queuing models. That is the first special Markovian queuing model, that is MM1Q. Then in the fifth lecture, we have discussed the simple Markovian queuing models other than MM1Q. Now we are moving into the sixth lecture, that is for the application of continuous time Markov chain in queuing networks. So basically the queuing network is nothing but a network consisting of several interconnecting queues. Either you can say network of queues or queuing network. In today's lecture, we are going to cover the queuing network as the application of a continuous time Markov chain. In the last 2 lectures, we have discussed the application of a CTMC, in particular birth-death process, but now we are moving into the more general setup of CTMC, that is coming in the queuing networks. That means that the underlying stochastic process of a queuing network is a more general continuous time Markov chain, whereas all the simple Markovian queues, the underlying stochastic process is the birth-death process. The study of queuing networks is going to be a very vast area. So, we are going to cover here only very simple queuing networks. The first one is a tandem queuing network. Then we are going to discuss the open queuing network, or we can say open Jackson queuing network, and also we are going to discuss the closed Jackson queuing network. Then followed by that, we are going to discuss the application of CTMC in performance analysis of wireless network system. If time permits, I will do it in this lecture, or I will go into the next lecture. So, now we are going to discuss the queuing network. Queuing network is nothing but a network consisting of several interconnecting queues. So, we have discussed already the queues in the 4th lecture. I am giving 3 different examples for the queuing network. So, you can say this as the first queue, or we can say the queuing network as the node 1, which consists of a separate one queue where the arrival comes waiting for the service. After the service is over, then it moves into the second queue, and this is the separate queues in which the arrival wait for the service. After the service is over, that it move into the next queue. Like that, it has many queues. So, this is the one simple example of a queuing networks, and this queuing network is called a tandem queuing network, because the output of a first queue is the input for the second queue, and there is no feedback. The output of the second queue is the input for the third queue, and so on. Like that, it is a system in which it has some finite number of queues in series. Therefore, this is called a tandem queuing network. Second type, this also consisting of many queues, interconnecting queues, whereas here the output of the first queue split in some probability, the summation of this probability and this probability is 1, and move it into the input for the second queue as well as third queue. If you label this as the node 1, node 2, node 3, node 4, node 5, therefore, this is a 5 nodes queuing network. The output of second queue and the third queue is the input for the third queue, whereas after the service completion of the third queue, with some probability the jobs or customers can move in again, come to the third queue. Therefore, this type of is called queues with feedback. We call it as a queues with feedback. Then the other proportion, it moved into the input for the fifth queue. After the service is completed, it goes away from the system. So, this type of queuing networks in which the arrivals comes from the outside some source and it departure from the system. There is a possibility the customers who finish the service in the fourth queue, it can depart from the system. So, this is the example for the open queuing network. The third type, here also we have 4 queues or 4 nodes. There is no output of queues from the from the system, as well as there is no input from the outside the domain. That means there is a constant number of customers or jobs will be moving from one node to the other nodes with these probabilities, and these probabilities are called the routing probabilities, in which after the service completed in the second queue, the customers or jobs move into the third queue. With some probability it will move into the fourth queue. Therefore, this probability is called the routing probability of jobs or customers moving from one node to the other nodes with some probability. This type is called a closed queuing network. So, even though I have started with some 3 examples, and these 3 examples are related to the different types of queuing networks, but before I move into the types of queuing networks, let me give the characteristics of queuing networks. So, what are all the minimum information is needed or is provided to study the queuing networks? It consists of nodes and interconnected. So, the interconnected are given by the information routing probability matrix. Suppose in this example, if the node 2, after the service is over, the packets or the customers or jobs are moving into the node 3, then the routing probability is P2 3. So, P is the matrix, routing probability matrix, and second row, third column element, it is corresponding to the routing probability of customers or jobs or packets moving from node 2 to node 3 after the service is completed. If that particular probability is 0, that means that routing probability there is no path from node 2 to node 3. So, we need a routing probability matrix. That matrix order is a number of nodes in the queuing networks, and the entries are the probabilities values. Therefore, it will be either it will be greater than or equal to 0 and lies between 0 to 1. Obviously, this routing probability matrix will be a stochastic matrix. The row sum is 1. All the entities are lies between 0 to 1. Now, what are all the information is needed in the each node or in the each queuing system inside the queuing networks? You have to provide the arrival process, arrival pattern. If it is inter arrival time is a random variable, then what is the distribution of that? Then you have to provide number of servers in each node, whether it is only one server or multi-server or infinite servers. Then what is the time taken for the service, whether it is a deterministic or probabilistic. If it is probabilistic, then what is the distribution of service time? For each node you have to provide. If it is one server, then what is the service time distribution? If it is more than one servers, then whether they are the identical servers or non-identical, and what is the distribution of each server's service time. Next, what is the capacity of the queuing system in each queues? In each, the whole queuing networks, what is the maximum number of jobs or customers are allowed as a waiting space, in the waiting space, whether infinite capacity system or finite capacity system. If it is a finite capacity system, then if the customers are coming from the previous some other node and if the system is full, then it will be blocked. So, therefore, we should consider what is the capacity of the each queues also. What is the scheduling policy? In what policy the customers are getting served in each queue. So, scheduling policy, whether it is a first come first served or a last come first served or a priority based or a random order. So, we should know what is the service, what is the scheduling policy for the each node. So, if you provide these 5 information for each node and the routing probability matrix, as well as what type of customers are coming into the whole queuing networks, whether only one type of customers are moving inside the different queues or more than one type of customers are in the system. Our interest in this course, how the CTMZ is used in the, or CTMZ is playing a role in a queuing network. Therefore, I am going to discuss a very simple queuing network in which you can able to map the underlying stochastic process with the CTMZ. Therefore, we can get some of the performance measures through the knowledge of CTMZ. Now, I am discussing the type of queuing networks. Even though I have explained the type of queuing networks through these 3 examples, like that you can frame many more queuing networks, but in this course I am going to cover only these 3 types of queuing networks. Therefore, I have given these 3 examples. So, through these 3 examples I am going to classify the queuing networks as the majorly in 2 parts, that is the open queuing network and the closed queuing network. What is the meaning of open queuing networks? The jobs or customers arrive from external sources, routed to other nodes and eventually depart. Therefore, there is a source and there is a sink also. The external source and it has eventually depart from the queuing networks also. Therefore, that type of queuing network is called the open queuing networks. The closed queuing networks has a fixed number of population, some constant capital K number of jobs or customers circulate continuously and never leave. So, that type of queuing network is called the closed queuing network. That means always if you count how many customers in the system means how many customers in each node. If you sum it up, then that total number is going to be always a capital K, that is the population size. Therefore, no one will leave the system and no one depart from the system also. So, it is a constant number of customers always there in the system at the different queues. You can always convert the closed queuing network into the open queuing network by including one source and a sink. You can convert the closed queuing network into open queuing network. So, in general we can classify the queuing networks as the open queuing network and closed queuing network.